Okay, we're going to talk now about graphing some linear inequalities in two variables. And this works fairly similarly to how we would graph an inequality on in just one variable. So remember, if I've got like x is greater than a 3, I've just I've just found my value of 3, so 0, 1, 2, 3. And then I'm saying, well, it cannot equal 3, so I can't fill in a dot right here, but it's going to be everything. I'll shade in everything to the right of that. If I've got, say, x is less than or equal to 1, well, just like before, I've got 0. Here's my 1, 2, 3. So here's that 1, -1, -2, -3. As soon as I say, oh, it's less than that or equal, I can fill in that dot and shade in to the left of that. Well, guess what? Something fairly similar happens every time we work with an inequality in two variables. So say I've got some line, and I'll do something like y is less than x plus 3. Here, whatever this line is, and I'm going to start out and make this fairly easy. I'll less than or equal to. That means that x and y, here's my 1, 2, 3, 4. I should probably do this on graph paper. In fact, I think we're going to do our next ones on graph paper. So when we graph this, and I'm not going to go into too much detail about how one is going to graph. I start by graphing the line, and because it can equal this point where, or on our line, this is where, everywhere on this line, this is where y is equal to x plus 3. And then we have to say, well, what if y is less than this x plus 3? So one of the things we'll do is we have to figure out where we're going to shade this. And I always like to say, one of the best places to try is check the origin. Because the easiest values that we can plug in are 0. So if I were to plug in 0, 0, let's see if 0 is less than or equal to 0 plus 3. Is 0 less than or equal to 3? It certainly is, which means that the origin, so this point, does satisfy this inequality, which means everything to the right all of this over here should get shaded in. So if it's, let's really quickly go through a couple little, let's give us a couple details here. I'm going to give us a couple methods that we're going to use, and then I'm going to do some more examples. So the first thing here is, if your inequality is like less than or equal to or greater than or equal to, then you are going to use a solid line. The solid line says that whatever is happening on that line can be a solution. If your inequality is less than or greater than, so not equal to, then use a dashed line. This is kind of equivalent to using that open circle. That open circle tells us that it cannot equal that point. And then we should test a point on either side of the line. So this is helping us figure out if something is going to be, if it satisfies it, then we'll shade in that side. So, and I like to say use the origin if possible. So the origin, which is that 0, 0 point, if it's possible. And if it satisfies the inequality, we're going to shade that side of the graph. Oops, I can spell of the graph. If it does not satisfy, you're going to shade the other side. You shade the other side. So here's if you haven't written these down, I'm going to say this might be a good place to pause and write these down, because we're about to do a couple more examples. So here we go. Let's say we've got y is greater than 2x plus 4. So again, I'm not going to go over how we're graphing the line. I'm just going to show how we're going to graph this inequality. So here I'm figuring out what points would be on this line, and it would be, I've got 4, this has got a slope of 2. So I'll have a graph that looks like, oops, I'm using a solid line and I shouldn't do that. This is going to be a dashed line. Because it cannot equal, it's not equaling anything on the line. The line here is just our boundary. This is just the boundary. Now let's try plugging in 0, 0. So if I were to say, oh, is 0 greater than 2 times 0 plus 4? No, 0, is 0 greater than 4? No, this is false, which tells us that 0, 0 does not satisfy our inequality. That means that every point, not this side, I'm not looking to shade in this side of my inequality. I'm going to shade in the other side. It's literally, we're just shading in 1/2 of our graph. And our line is our boundary. Now, if I were to check any other point over here, if I were to check, say, -10, 0. Oh, let's see if that would work. Oh, 0 is greater than 2 times -10 plus 4. Oh yeah, 0 is in fact greater than -20 plus 4. Yeah, 0 is definitely bigger than -16. That would be this point over here. And I could check every single point on this side of my graph. and that would satisfy this inequality. Let's do another one. I'm going to take kind of the same line. I'm going to say, oh, let's do y is, how about I do y is lesser than or equal to this 2x plus 4. So again, I'm kind of keeping this same line. I'm just going to show you how the tests show us what we're solving for here, or what side we're shading. So I will draw my axes here. There's my x, here's my y, and oops. Here this can equal, so I'm going to use a solid line. And again, I'm not going to go over all of the hows I'm graphing here. I'm using the intercept and slope to find that. But now I'm going to test the origin. Test that 0, 0 again. So here we've got that y is less than or equal to this 2x plus 4. I probably should have written this up above here, but I didn't. So what we're doing is we're plugging in 0 for x and 0 for y. So is 0 less than or equal to 2 times 0 plus 4? 0 is in fact less than 4. So this point right here does satisfy this inequality. And if we were to test any, or in fact all of the points on this side of the inequality, I would discover that they all work. So I'm going to shade in, I'm basically shading in this whole entire side of the graph. All right, I've got there's a couple sort of interesting examples that we can try. I'm going to show you a few of the other ones. If I'm thinking of any equation, if I think of any equation as being two variable, I could also just as easily say, oh, well, what happens if I've got, if I say, oh, x is greater than 5. Okay, well, if I were to just graph the line of x is equal to 5, I would have a vertical line. And the funny thing here is every point now, anytime I choose a value, so if I were to plug in 0, 0, x is 0, is that, if I were to say, check the origin. Okay, is 0 greater than 5? I've got this x greater than 5. No, it's going to be the other side. So I will shade in everything to the right on my graph. If I were to do a vertical line, or not a vertical line, a horizontal line, say I've got y is less than or equal to -2. Okay, if I were graphing this is a horizontal line. Here's my x, here's my y. This line would be a solid line because it could equal, and it's just going to be, well, y would be a constant, so it would just be, I'd have my line right here, where we have that. If x is less than or equal to -2, if I were to test our origin again, let's say we check that 0, 0. Again, if I've got y less than or equal to -2, oh, is 0 less than or equal to -2? Actually, it isn't. So instead of shading in above this line, we're going to shade in below it. Alrighty. That's all we've got for right now, and I hope to see you in the next video.